Hello, my name is Ethan Jones, and today I'll be giving you a rundown on the developer side of this project, which is a heart disease screening questionnaire. We will start here, which is what the user will be interfacing with. Now, this is the Google form. This is all the user will ever have to interact with, is this set of questions. They will input the parameters asked for, and within 24 hours, they will get a response from our system. They will get a response through this last question where they have to enter a valid email address. If this address is not entered correctly, they will not receive a valid email response. When responses are recorded, they are recorded to this Google Sheet here. This is what the program itself will be interfacing with to grab data and parse it later. Let's move to the program. There are two steps to this program, the initialization training runner and the main runner. We will start with our initialization and training. Now, this will go through a few steps. I'll walk through it one by one. First, we're going to write our CSV file path. And this is where we'll be writing the data that we query from the SQL database right here under the Connect to Heart Disease and on the Write History functions. Let's move to Connect to Heart Disease under the PySQL script. This simply establishes connection to the local database. Easy. Now, we're going to go to Big Data and Write History. Write History is going to query again. Now, the reason this will call PySQL is for an organizational reason, so that all SQL queries are done through psqlc.py. So get from heart disease is going to grab from the undersampled data table, which is 40,000 entries, 20,000 positive and 20,000 negative for heart disease, and write them to the CSV file path of historyholder.csv. Now, in init, if we run training.studyhistory, we will pass that CSV file path through. Now let's move to training, and here we are. We're going to establish a data frame. Now this is a way for us to frame our data, obviously, and we will use it by populating all the information from that CSV file path that was just written to in PySQL in a PySQL query. And that data frame will then be formatted using a dummies function. Now, dummies are a way of reorienting data, such as true and false, into instead ones and zeros. For instance, smoking will return a yes or a no when asked on the survey. But when dealing with a linear regression formula, which is the sort of machine learning that is being used here, that is not an acceptable entry. It must be an integer of 1 or 0. Or true or false, not as strings, but as a Boolean. So data frame alt will then be this formatted data frame, passing the data frame through the dummies function to get data frame alt, which is the dummies. We are then going to set x to data frame alt and these parameters. Now let's take, for instance, age category 25 to 29. This is either going to be a 1 if the user answered yes to that, or a 0 if they indicated something else, because there are several categories they could pick here. For instance, if the user answered on the survey that their age category was 50 to 54, then only this row will be a 1. All of the ones here will be zeros, and all of the ones here will also be zeros. That way, they can be treated as that risk factor properly. And the weights can be properly assigned between them. Now, we are then going to train this model on the SK linear model linear regression function, and then use model fit with those values to create our trained model. Our trained model is then going to be dumped into a .sav file using a pickle function. Now this here is a test to ensure that pickle function works, and these here are some static test data that we will have recorded answers of to ensure consistency in our algorithm. Now we will now run an init training runner just to show what it is capable of. And there we have it. It's done. That is all it takes to train the bot. It has just queried all of the 40,000 entries, parsed the dummies, see 39,999 rows, so not quite 40,000, and then parsed them into these data frames. And our two test information gave us these responses. And we went back to double check. Here they are. That is all we are doing with init. Init is done. The information exists under this SAV file, trained model, as binary, because we wrote into WB, write binary, because this is a logic file. It is not a CSV. This is designed for us to be able to use that information later. We will no longer use Pickle or Big Data or init. They are all done, but PySQL connector will be used again quite frequently. Let's move to our main runner. Now, a main runner is the main program. The training is just to get the bot into a state that the main runner can utilize the information that it was trained on. Let's go step by step. First, you'll see that we are in a continuous while loop. And we have a time sleep 1. And this while loop will only end when the program is terminated. This is to be sure that when we reach the end and we inform the user of our decision, we are back to the beginning to poll for the next one. Obviously, we need to connect to the database again because the connection from our last run has been terminated. This is where the time comes in, and we are going to set our entry num. Entry num is just the entry number, this entry's number, and we are going to get it from the Google Sheet Looker look for new function. Let's look there now. First thing we'll notice is scopes and service account. Now these are matched to this authorize function. The authorize function uses this code to generate a token to allow interfacing between the program and the Google API software. This does not return anything. It runs every time the program runs, and it simply allows that when I say this service account matches, if that matches the service account tied to this client secret, then I'm in business. Which, as I will demonstrate later, I am in business. Looking at look for new, we set our credentials using the token generated. We set our service. Our sheet is set to the sheet ID of the spreadsheet we'll be reading. And then here is where we'll get our latest entry. Now this will go through PySQL get patient table size. If we look here, that's only going to get the table size of new patients. New patients is entirely populated from the entries we receive. Meaning, if we received 2 entries in the same second, despite it only polling once every second, it will only ever grab the next entry. It will not grab the newest. It will grab the next. This is a first in, first out methodology. It is going to return the size of that to Google Sheet Looker, and it's going to use this size to determine whether or not the next row is populated or unpopulated. It will check the first value and say if that value is not null, well then we have our Goog size. But if it is the same, because when we get to the not null, it says to the latest entry, it's going to loop again. This time, since Goog size equals latest entry, because we've set it up here, we're done looping. We can exit our loop by x plus 1 and return that latest entry because that latest entry size has been updated to match the latest row on the Google Sheet. That way, we know exactly which row we need to grab data from. Now, this is return to main, where we're going to set all of these parameters equal to the results of googsheetgrabber.patientinfo. Let's move to Google Sheet Grabber. Now, Google Sheet Grabber, once again, establishes with the service account and the scopes through authorize. Here's our patient info. Credentials, it uses the same JSON token. Service, sheets v4, and the same credentials, same sheet ID. Now, the range is set to the column name, or column B right here, and plus the string of entry number, which is the row number. So in this case, it's going to be the next row, because we only move into Google Sheet Grabber after Google Sheet Looker has found new information. So we know we are going to be grabbing a row of information that has not been grabbed before. Now, all of this information is meant to parse the results of each cell into a usable variable. So, since we actually grab the cell not as a variable, but rather as a list within a list, we have to get the value of the first entry of the list of lists, and then that list, we have to grab the first value of the list, and then parse it as the proper data type. Those get returned en masse to main. And then a new patient object is created for ease of use. It's time to make our decision. Now, decision is using the smart script. Smart.makePrediction. Now, for the values in which we already have integer values, or numerical values, we do not need to do anything special. Height and weight are calculated into BMI. Physical health is out of 30 days, so it's a numerical value. So is mental health, sleep time, a number of hours is a numerical value. But when we get to non-numerical values, for instance, if the new patient smoking is yes in the column, we cannot pass that string into the fit function. We have to pass a true or false. So we're going to go through, and for the ones that are one are true or false, which is true or false, true or false, but the ones where there are multiple, they have to be set to false by default, and then true only if they match the string. And then at the end is where the actual logic is going to take place. Now, logic file is going to be set to just the name trainedmodel.sav, and we are going to open that file, trainedmodel.sav, and RB, read binary. And this new model, model read, which is just like our model we used earlier, is going to load the pickle file. We're unpickling the binary file here so that we can use it. And we are going to do this predicted heart disease patient, which is going to be the value between 0 and 1 that we get from that. And we're going to do a model read.predict function using all of that information. And it will return a value between 0 and 1. And if that value is greater than 0.5, they're at risk of heart disease, because more of the risk factors is more likely. And then if it is 0.5 or less, then it will return false. Less of the risk factors, less risk of heart disease. Now, once we've returned decision, we're going to do two things with it. The first is that we are going to add that patient's information into the new patient's table. This will update the table size and ensure that we can continue polling. We are then going to send the results to the user using the email provided. So mailman.contactuser, it's going to send the decision and the email over to mailman, where it's going to use SMTP protocol, where if decision is true, it sends this statement, and if it's false, it sends this statement. And it's going to send it to the recipient of the email provided. And we're done. We're now going to delete that entry to make sure that these variables can be reused, and resume our polling right back here at the top, where we're going to make sure we are connected. We're going to wait 1 second, And then we're going to start looking for new in Google Sheet Looker again. And of course, Google Sheet Looker will continue to poll as long as the sheet value is less than the size of the entry. We will run main runner in a moment, but first we're going to input some test data into the response link. So let's submit a response here. Let's say we are 65 inches tall. We weigh 130. We don't smoke. We don't consume alcohol. I won't go through all of these verbally, but I will show you. And you follow along and see that this is the physical health, and you can see it is an integer. And it will be passed as such. But these are strings and need to be converted to trues and falses. And now, again, it has to be a valid email address. Let's do and again, I'm double checking because it has to be valid. And we'll submit. Now, you can see that it has populated in the Google Sheet. There's a new entry. There's now 7 entries. 2, 3, 4, 5, 6, 7, 8. So 2 is the first, 8 is the 7th. And if I run main, it's going to grab a size of 6 and decide that since there's a 7th entry, it's time to act on it. So let's run our program, and it will detect the new information. See, it grabbed a size of 6, but since there's 7 entries, it knows it needs to keep going. And there, false. There's our response. And now there's a size of 7, ticking none, ticking none. That means it's not seeing anything. Let's check our email, because we will have received a response from the bot. Heart disease screening results. And there is our pre-typed message. Thank you for listening. I understand that moving all of these parts together when it comes to Google APIs, Google Sheets, Google Forms, SMTP, local MySQL table can be very difficult. So I hope this video has shown and demonstrated the capabilities of the program as described and serves as proof of concept. If you do wish to go about setting your own, I will now show you exactly where those authorizations need to be. Under here, this needs to be the information for your local database user. So whatever you name your local database, it needs to match these. When you do your authorizations, the service account needs to match the service account that you've created the Google API project with. The rest of it can remain the same. Here under Google Sheet Looker and Google Sheet Grabber, these service accounts need to be the service account under which you've made the project. And they need to be corresponding to the secret produced here. So the secret produced on here has to be linked through the same project that the service account here is linked to. Thank you for your time. I hope this has been valuable and helpful. Have a nice day.